In October 2017, astronomers detected something entirely new, a visitor from beyond our solar system, traveling across its vast expanse. This interstellar traveler, the first of its kind ever observed, baffled scientists due to its strange behavior and origin. It was named Oumuamua, a Hawaiian word for messenger or scout, in reference to its potential status as a messenger from distant cosmic realms. The discovery raised global interest, intriguing astronomers and space fans alike. Its arrival was a milestone in space science, generating speculation, theories, and arguments about its nature, origins, and what secrets it might contain. With the powerful James Webb Space Telescope, JWST, operating today, humanity has taken a giant leap to unraveling Oumuamua's secret. This cutting-edge observatory has given us the first detailed image of this enigmatic interstellar traveler. Unlike any comet we've seen before, Oumuamua exhibited no visible tail, no cloud of gas or dust to suggest traditional outgassing. And unlike typical asteroids, its motion away from the sun couldn't be explained by gravitational interactions or any known physical force. These anomalies contributed to the mystery, compelling scientists to search outside standard models for answers. Through the help of Webb, we are now at last able to peer more keenly into the unknown. Since its discovery, Oumuamua has inspired countless theories, ranging from relatively mundane to wildly creative. Some scientists proposed that it was composed of hydrogen ice, an exotic form of matter which could explain its acceleration. Others were bold enough to suggest that it could be a probe or vessel of an advanced extraterrestrial civilization, sent to explore the galaxy. The truth, however, was concealed. No single theory has been able to provide a completely satisfactory explanation for all its characteristics. With traditional tools offering little data, astronomers looked to the James Webb Space Telescope in the hope that its advanced capabilities would finally provide answers. The James Webb Space Telescope, which took flight in December of 2021, was designed with only one goal in mind: to observe further out in space than any previous telescope and unlock the universe's greatest secrets. Unlike its predecessors, Webb can see the universe in the infrared part of the spectrum, and so is able to detect and analyze weak heat signals from distant or cold objects. This is vital when analyzing faraway or distant objects like Oumuamua. As Webb aimed its keen instruments at the target, now traveling far beyond the inner solar system, it took a historic photograph. This object had never been seen so clearly, in such detail. The image revealed that Oumuamua was an elongated, asymmetrical form unlike any known comet or asteroid. Its surface is pockmarked, too, with deep grooves and ancient craters, a record of billions of years of traveling the harsh and empty expanses of interstellar space. These are signs that can be taken to tell the story of hits against dust grains, cosmic rays, or passes through high-energy environments hundreds or thousands of light-years distant. Its peculiar geometry raised more questions in one's mind. Was it naturally built, or was its shape the result of some sort of cataclysm? The mystery of its shape was heightened, but for the first time we had direct visual proof of its alien form. Even more enticing than Oumuamua's shape was its chemistry. Webb's observations detected complex organic molecules with carbon and usually associated with life or pre-life chemistry. These were mixed with ingredients never or hardly ever seen in our galaxy, which means that Oumuamua may have had its birth in some other region of the galaxy under a fairly different set of conditions. The find points towards an extragalactic origin like nothing we know, a star system of unusual chemistry and dynamics. This makes Oumuamua not only a space rock, it's perhaps a sample from a completely different stellar environment and contains clues to how other systems form matter and build planets. One of the most perplexing aspects of Oumuamua was its enigmatic acceleration. As it exited our solar system, it accelerated slightly, behavior that gravity alone couldn't account for. Comets would speed up due to outgassing, but no such jets were found. With Webb's highly precise instruments, scientists could rule out traditional explanations and investigate novel ones. Perhaps the most fascinating theory is that Oumuamua is powered by a light sail, a hypothetical future technology concept in which a vessel is driven through space with the momentum of photons from stars. If true, it would imply not just intelligence but alien engineering. With its infrared sensors, Webb analyzed the light reflecting off the surface of Oumuamua and uncovered a treasure trove of data. The spectrum analysis showed a mixture of metallic and mineral compounds which don't naturally occur in our solar system, and the faint trace of chemicals which may come together to create organic molecules under optimal conditions. The object's reflective surface is made up of materials that can be credited for its brightness, another phenomenon waiting to be explained. These materials indicate that Oumuamua might have originated in a young, unstable star system, likely near a supernova or in an energy-rich area where exotic materials are more common. The new information gives astronomers unmatched insight into what matter does in other regions of the universe. In contrast to the relatively stable and predictable character of our solar system, the origin of Oumuamua might be a dynamic, chaotic area where planets are being destroyed, created, and reshaped rapidly. The fact that such an object exists defies our current knowledge of planetary formation and interstellar processes. If Oumuamua is representative of the material ejected by other star systems, it means the galaxy is full of objects created in completely alien processes, each with its own history of its star system, its chemistry, and its cataclysmic events. One especially interesting speculation is that Oumuamua is the remnant of a planet destroyed by extreme gravitational forces, perhaps from a nearby black hole or a supergiant star about to collapse. These gigantic forces could rip a planet to shreds, sending shreds flying through space. If Oumuamua is a shred, it would be one of the lucky few from a cataclysmic process, shaped by forces far more powerful than we normally witness. Its study could tell us about the process of star and planet formation, and how such astronomical catastrophes influence the matter pattern in the galaxy. Thus, Oumuamua could hold the secrets of life and death of entire worlds. The finding of organic material on the surface of Oumuamua has already set the stage for even more intriguing questions. Some scientists now wonder whether such bodies are maybe natural pathways for delivering building blocks of life to scatter across the galaxy. That idea, a form of interstellar panspermia, is that life, or at least the components thereof, would travel between star systems as meteors, comets, or even as Oumuamua itself. If so, what it would mean is that life seeds are more common throughout the universe than we had ever imagined. Oumuamua may be more than a scientific marvel. It may be an emissary carrying with it vital information regarding the creation and spread of life. That would have basic implications not just for science, but for the place of human beings in the universe. If life can spread between star systems, then perhaps Earth itself was seeded by similar objects long ago. In turn, Earth-originated life might one day be spread to distant worlds, either intentionally or by accident. Oumuamua's strange presence reminds us that we're part of a broader cosmic story, one full of mystery, change, and connection. It is a time capsule from another location and time, bearing messages inscribed in its composition and structure. Every new finding about it redefines our knowledge of the origins and possibilities of life. The continued study of Oumuamua opens the door to future missions and technological advancements. Scientists are now designing space missions specifically for intercepting such objects in the future, with equipment to examine them up close. These missions can redefine what we know about interstellar matter and introduce us to first-hand knowledge on material that originates beyond our solar system. By studying objects like Oumuamua, we also learn about star evolution, formation, and how they interact with one another. Ultimately, this research will enable us to write a more complete history of our galaxy, the one with the extraterrestrial encounter with objects shaped by unseen forces from the distance. The passage of Oumuamua to our solar system also has a very deep philosophical importance. It reminds us of how small we are in the grand scheme of the universe and of how it may be possible that we are not alone. In case what occurs is that this body is something created by or created through intelligent life, then this would be the first indirect contact with alien life, something that would change the world we live in forever. Even if it is utterly natural, its odd nature opens our eyes to what the universe might contain. Either way, Oumuamua is a cosmological wake-up call that inspires us to go beyond our complacent horizons. The passage of this enigmatic object has motivated a new generation of scientists and engineers to now look outward, beyond our sun, beyond our solar system. Ambitious missions like Breakthrough Starshot are in the works, with the aim of dispatching ultra-fast probes to close-by stars through light sail technology. These journeys are no longer science fiction. Instead, they represent the beginning of interstellar exploration. Learning about objects like Oumuamua gives us both the wonder and the drive to venture out and investigate other star systems for ourselves. This is the beginning of a new age, where humanity doesn't just gaze upon the stars at a distance, but wants to join them. With each new discovery, we are brought nearer to an era when human beings will interact with the universe in ways previously unimaginable. Instead of simply observing it with telescopes, one day we could send robot expeditions, or even humans, to tour distant cosmic events. Oumuamua is an indication of that. Its brief call to our solar system reminds us that we are in a continuum and not an isolated one, but a part of a very grand cosmic drama of events and exchanges. In building the tools to seek out and explore such interstellar visitors, we prepare ourselves for more. Our destiny may be among the stars, and Oumuamua is an introduction. Oumuamua, the interstellar messenger, is not just a rock that came through our solar system. It's a doorway to a universe of promise and questions. Its discovery has changed astronomy and opened up conversations beyond science. What's out there? Where did it come from? Could other objects like it be